Hello everyone, hope you all are doing good. Today we are going to learn a simple topic, that is lines and angles. It is of 9th standard chapter. In this we are going to learn specifically about some of the basic terms and definitions. Let us see. The first concept is points. In this we are going to learn two more concepts, that is collinear points and non-collinear points. So you can see this map as there are a lot of dots here. So these dots represent the location of either it may be a place, or it may be a building, or it may be some kind of a road. So simply what we can say, it is nothing but a location. What a point is a location. So continuing on that, it also says it has no size, no width, no length, no depth. So it makes sense, right? When you put a point or when you draw a point, it will not have a particular size, width, length and depth. Means it will not have a specific size or a width or a length or a depth. And it is also represented by an alphabet. So you can see here, there is a point I have drawn, okay? I have given it a name as A. So let us continue with the collinear points. So in the collinear points, you can see I have drawn 3 points with the 3 different colors. Okay. If I draw a line, this line passes through all the 3 points P, Q and R. Okay. So such points are called as collinear points. That means 3 or more points. Okay. If they are on the line, or we can see if they are on the same line, then what about this? Now if I try to draw a line through these points, you can see here one line can pass through only 2 points. Now presently it passed through X and Z. This is X and Y and this is Y and Z. By this what we can see, we don't have one single line which passes through all the 3 points X, Y and Z. So that is what non-collinear points are. So let us continue to the next topic now. So this is lines part 1. So actually I have made lines into 2 parts. It is going to be the first part. It is the most basic concept. So here we are going to discuss about line segment and ray. Let's start with the lines. What is lines? We can say that lines are collection of points. Okay. Before that you can see I have taken only 5 points. Okay. These 5 points doesn't make any line. So if I add some more points to it, so as you can see in the definition, it's a collection of infinite number of points. So to match with this definition, I will add some more points. So if I add these points, you can see it is not a line. So what happens? We have to increase the number of points. As I go on increasing the number of points, it appears to be like a line. Okay. Now how exactly we are going to represent the line then? So this is the way. You can see here this line is AB and its ends are arrows, right? That means this can be extended in both the directions. That's what it means. Okay, in the definition you can see it has no end points. That means this line can be extended in both the directions. So next let us go to line segment. As you can see here, it is a part of a line with the 2 end points. So this is an example. Here you can see A and B. They don't have any arrowheads. Instead of that, they have a points, that is A and B. Let us go to a ray. As a definition, it is a part of a line with only one end point. Only one end point means the other end point is going to be an arrowhead. So you can see here M is an end point, B has an arrowhead. That means this line can be extended only in the direction of M to B. That means in the direction of MB we can extend this. So let us continue with the next basic concept, that is angles. So angles are formed by 2 rays. So when 2 rays OA and OB are drawn from point O, there forms an angle. Let us learn some more about these angles. Okay. So here also I have taken angles part 1 because there is one more part which includes some different type of angles. The first one is acute. Most of us know acute angle. So here what happens? The angle, see this is an example for that. So measure of this angle is 60 degree. The 60 degree lies between 0 degree to 90 degree. Okay, any angle between 0 to 90 we call that as acute angle. Now second angle is right angle. Right angle represents 90 degree. So you can see here, this shows a 90-degree angle, correct? So that means what? Angle A is equals to 90. The next one is obtuse angle. So you can guess it now. Obtuse angle means what? It should be more than 90 but less than 180. So you can see here, this angle is almost equal to, or we can say exactly equal to 170 degree. This is how we represent this as angle A is greater than 90 degree but less than 180 degree. So what do you call an angle if it is 180 degree? It is straight angle. So here angle A is equal to 180 degree. Now let us continue with this. If the angle is more than 180, we call it as a reflex angle. You can see in the diagram how it is, correct? This angle is almost 280 degree. So reflex angles are greater than 180 and less than 360. Then what do you call an angle which is equal to 360? So it is nothing but a complete angle, where angle A is equals to 360 degree. That means it is a complete angle. So let us continue with the next topic, lines part 2. So here we will have two more types of line. One is intersecting lines and the other one is non-intersecting lines. So let us say what does they mean. So you can see some pictures here. Here we can see some lines. So it feels that these lines are never going to meet. So we can call them as non-intersecting lines. In this railway tracks we can see two types of lines. Some railway tracks are meeting each other, or we can say they are intersecting each other, and some lines feel like they never meet each other. So that means it includes both intersecting and non-intersecting. And this tracks, okay, we can say running tracks. If you see that, here we have a non-intersecting lines. And you can see the TV tower. TV towers are arranged in such a way that those metal bars, they are, some places they are intersecting and some are non-intersecting. Okay, these are some applications of these two. So how exactly we can draw intersecting and non-intersecting lines? That is like this. You can see here. So these two are AB and PQ are intersecting lines. So they are intersecting at point O. Now AB and CD are parallel lines which are not at all intersecting, and as much as you want you can extend this, but they will never meet. So let's go to next, pair of angles. Pair of angles means, as the name itself it says, there are two angles. So let us start with that. So in this pair of angles, I will call it as a part 2 because here we are going to learn many types of angles. So the first one is complementary angles. Complementary angle means, see the picture you can see, it shows 90 degree, right? And it is complementary angle. That means there should be two angles. So if I divide this 90 degree angle into two parts, I will get two different angles. But when I add these two angles, I will get 90. So any two angles, when you add it, if you get 90, that goes under complementary angles. Let's go to next, supplementary angle. You can guess it. The previous one is a complementary angle. By adding, we are getting 90 in the sense. Second one, what may be? Yeah. Now this shows 180 degree. So let me see, I am going to divide this angle. So now it is divided into two parts. So again angle 1 and angle 2. Here what happens, when you add these two angles, we will get 180 degree. Such angles are called as supplementary angles. Let us continue with this, adjacent angles. Remember, adjacent angles are those angles which have a common arm. Here you can see angle 1 and angle 2 are divided by the line with the blue color, right? So they are on the either side of this particular line. So we can call these two as adjacent angles. So let's go to linear pairs. Linear pair and supplementary angles, they almost mean the same thing, that their sum is going to be 180 degree. So let's go to next, the vertically opposite angles. The opposite angles are always equal. As you can see here, the 1 and 3 are opposite angles and 2 and 4 are opposite angles, they remain always equal. So let us continue with the next type of angles. You can see now I have drawn up parallel lines. That means we are going to discuss about angles which are on the parallel lines. Now here we can call PQ as a transversal which intersects AB and CD at two different points R and S. So let us start with the first type of angle, okay, alternate angles. So here you can see I have highlighted a region between the parallel lines. We call that as interior region. So let us start with the first type, that is alternate interior angles. You can see here these two angles, angle ARS and angle RSD, which is highlighted with the yellow color. These two are called as alternate interior angles, and we have one more pair, that is the other way, that is BRS and CSR. So this is in the interior region, so we call them as interior alternate angles. So next one is going to be, you can guess it, it's going to be an exterior alternate angles. So these are the first pair, okay, then this is the second pair. So next one is corresponding angles. So we can remember one way that corresponding angles will be always on the same side of the line. So you can see here angle ARP and angle CSR are the corresponding angles. Now if you closely observe, we may get three more pairs of corresponding angles. Let us see that. See, PRB and RST. Then again if I take the downwards, that is ARS and CSQ, and one more pair, that is BRS and DSQ. So these are corresponding angles. Now the last type of angle, co-interior angles. In this what it is, the angle BRS and DSR, these two are called as co-interior angles, and one more pair we will get, because you can see here it is co-interior angles, right? So I have taken one side of the line, so I will get one more pair on the other side of the line also, that is ARS and CSR. So these two are also co-interior angles. The speciality of co-interior angles is that when you add these two angles, you will get 180 degrees. Thanks for watching.